I was explaining about cation and anions, isn't it? So one example is ionic radius of F minus. F minus means, you know what is the name of it? You call it as fluoride ion. What do you call? Fluoride ion. Ionic radius. Okay, now before moving on to this example, let me tell you what is ionic radius now. The distance between cation and anion in a crystal lattice. That means, say if you say NaCl, this is an example for ionic compound. Ionic compound, why you know? Because here Na will be positively charged, Cl will be negatively charged. So they form a structure this way, Na plus then Cl minus. Na plus Cl minus. If you observe its structure, it will be this way. One Na plus, next will be Cl minus. Na plus Cl minus, this way. Okay, it continues. See, Na plus alternate Cl minus, Na plus alternate Cl minus, that way. Here it is made up of anion and cation. So the distance between the positively charged ion and the negatively charged ion, now you call as ionic radius. Clear? What is ionic radius? The distance between the center of cation and anion in the crystal lattice. In the crystal lattice, Lattice is called ionic radius. That will be the definition for ionic radius. Now example is, I was telling you that cation will have smaller size than parent, anion will have larger size than parent. How? An example. Ionic radius for fluoride ion is 136 picometer. Same way, whereas its atomic radius, see this is ionic radius, that means in ion it is 136 picometer, whereas atomic radius of fluorine, now you don't call it as fluoride. Why? This is an atom. How do you call? Fluorine. Atomic radius of fluorine is 72 picometer. See, you can find the difference now. This is the parent. Fluorine is the parent. Fluoride, F minus, is the anion formed. How anion is formed? By attracting electron or by gaining electron. Earlier the size was 72 picometer, but now after gaining electron it has become 136 picometer. Clear? Same way, in case of cation we will see ionic radius of Na plus. Na plus means it is cation. It is around 95 picometer, whereas atomic radius of sodium, atomic radius of sodium is 186 picometer. 186 picometer. So you can see this is cation where it has gained or where it has lost the electron, so it has become positively charged. It is 95 picometer, whereas atomic radius of sodium, which is the parent, is 186 picometer. So you can make out the difference. Earlier the size was large, but now since it has lost the electron, the other electron will experience more nuclear pull, and that is why the size has been decreased. Now it is 95 picometer. Hope it is clear. Okay, let us move on with the next concept. So this was the example for the size of cation and anion. Now let us see what are isoelectronic species? There are some species, ionic species, where you see that they will be having same number of electrons. Iso means same, electronic means it is related to electrons, species. So what are isoelectronic species? Iso means same, electrons, species. So how do you define it? Species having same number of electrons are called isoelectronic species. Now let me give you some examples, okay? Examples, most common examples that will be asked for isoelectronic species. It's important for the competitive exams as well, because they can ask you questions based on isoelectronic species. O2 minus, F minus, Na plus and Mg2 plus. These are called as isoelectronic species. Now a question may arise that these are all different atoms. How come the number of electrons will be same, isn't it? So let us see how. So if you can think of, write their atomic number. What is the atomic number of oxygen? 8. Fluorine 9. Yes. Sodium 11. Magnesium 12. Its atomic number Z. Now see, oxygen has 2 extra electrons. That means first it had 8. Atomic number means number of protons. Number of protons is equal to number of electrons also. So how many electrons it had? Oxygen had 8 electrons. Now it has gained 2 extra electrons. So 8 plus 2, 10. So how many electrons it has now? Now it has 10 electrons. Same way fluorine, you see, earlier it had 9. That means atomic number was 9. That means number of protons or number of electrons is 9. It has 1 extra charge now, minus. That means it has gained 1 electron. 9 plus 1, how much? 10. Sodium's atomic number is 11. That means it has 11 electrons in it. But Na plus means how many electrons it has lost? It has lost 1 electron. So one positive charge is extra there. So 11 minus 1 I will have to write. Are you getting the point? Why? Because it has lost 1 electron. So it is 10. Mg2 plus. Mg2 plus, again magnesium. Atomic number is 12. How many electrons it has lost? It has lost 2 electrons, and that is why it has become Mg2 plus minus 2. 12 minus 2, again 10. Now you see the number of electrons in all these cases. It all has 10 electrons each. That means these species are now called as isoelectronic species. Are you getting the point? So how do you define isoelectronic species? Species having same number of electrons. These are example for one set of isoelectronic species. There can be other species having same number of electrons this way. This is an example. Please do remember this because it's very important. They keep asking questions based on this as well. Let's move on to next one. They can ask you a question based on the size of cation, anion also. So one question, one in-text question that has been solved here is, which of the following species has smallest and largest size? Mg, question is Mg, Mg2 plus, Al, Al3 plus is given. And the question is, which one among these has smallest and largest size. Smallest and largest size. Now if you observe, what is the atomic number of magnesium? Magnesium is 12. What is Mg2 plus? Mg2 plus is its cation. This is parent. This is its cation. What has happened here? It has lost 2 electrons, because of which 2 positive charges are extra now. So what will be the size now? Whether this will be larger in size or smaller in size. Compared to this, Mg2 plus will have smaller size. Okay. Leave it. Al3 plus. Yeah. Now it is this way. Atomic number is 12. After magnesium comes aluminium, which is 13. Across the period, what happens to the atomic size? It increases or decreases? Atomic size always decreases, isn't it? That means magnesium will have larger size. As you move on to the right side, the size goes on decreasing. Yes. So already aluminium has smaller size. Now aluminium has lost 3 electrons and it has become Al3 plus. That means compared to the parent aluminium, now Al3 plus will have still smaller size. Compared to magnesium, the parent, Mg2 plus will have smaller size. Are you getting? Now you compare which one has smallest and largest size. Here across the period, if you check among magnesium and aluminium only, then you know aluminium will have smaller size, because the electrons are added to the same shell, the nuclear charge increases and size decreases. So magnesium will be larger. And if you compare Mg2 plus and Al3 plus, again compared to their parent, they will have still smaller size. So Mg2 plus will have smaller size, Al3 plus will have smaller size. See, one more thing how you can remember is, here it has 2 plus charge, here it has 3 plus charge. More the positive charge, smaller will be its size. But you need to keep the atomic number again in your mind. So which one has larger size? Mg has larger size. Which one has smaller size? Al3 plus has smaller size among these. Just make a note of it. Next very important concept is ionization enthalpy. Ionization enthalpy. About enthalpy in detail you will be studying in a unit called as thermodynamics. In simpler words, let me tell you, it is related to the heat changes. Okay, the measure where you consider the heat changes and express, it comes under the term enthalpy. So don't worry about it. I will be explaining it in detail in the unit thermodynamics. You'll get to know about it. Okay. Now ionization enthalpy, what is it? Why I have erased this is because I had told you, once you understand atomic size concept, then the concept of ionization enthalpy or any other concept becomes easier for you. This is one more important property called as ionization enthalpy. What we have studied now, atomic radii we studied, ionic radius we studied. Now next one is ionization enthalpy. Ionization means, what comes to your mind? Ionization means where something is being dispersed into ions. Ionization, formation of ions. Remember that way. Enthalpy means the heat changes, or in simpler words we say the enthalpy change related to ionization. How we can define ionization enthalpy is the energy required to remove an electron. Now Say we have an atom with positive charge at the center, which is nucleus. So it has different shells. We have outermost electrons this way. Now we want to remove the outermost electron. Why we want to remove the outermost electron? It's not that just like that we can remove the electrons, but during the formation of compound or a molecule, when the chemical reactions takes place, usually there will be exchange of ions. For example, we had taken sodium chloride as example, isn't it? Here what has happened, sodium gives one electron to Cl minus, because Cl minus chlorine will have one electron less than noble gas configuration. It wants to become stable. You have studied about stability again. If it has completely filled, or if it has 8 electrons in the outermost shell, then it will be more stable. Yes. So chlorine will be in need of one electron, whereas sodium, it wants to lose one electron. So they will understand each other, and sodium will donate one electron to chlorine. So chlorine will be happy. Now even sodium is happy. They form a good bonding now. Now a new molecule, sodium chloride, has been formed, which will have different property than sodium and chlorine. Now the same way, say now sodium has to lose an electron. How it can? Simply it cannot lose electron. So it needs some energy, because nucleus will be holding all the electrons. Now if you have to remove one electron, then you will have to see that the energy that you supply must be greater than the nuclear pull. So you must supply some energy. Energy can be in the form of heat or light or radiation also. The energy required to remove the outermost electron from a gaseous, neutral, isolated atom. See, I am mentioning you these terms. It must be a gas. It must be in gaseous state. Why? If it is in gaseous state, then it is easy for the removal of electron, because intermolecular forces, that is the force inside, will be bit weak. Gaseous. Neutral means where it has not lost any electron nor gained any electron. It's neutral. All the positive charges balanced by all the negative charges. So we say neutral. Isolated means it should not have formed any molecule already. It should not have formed any bond. It must be in its free state. So we say isolated. Isolated means separated. That means if you want to define ionization enthalpy, then you must keep it in your mind that if I say ionization enthalpy for sodium is this much, that means we are considering it in gaseous state, neutral and isolated state. Clear? So how do you define ionization enthalpy? Ionization enthalpy is defined as the, or you can say it is a measure of energy required to remove an outermost electron from gaseous, neutral and isolated atom. That is why I always say that if you have a picturization, then you can remember the concept better and put it in words. So if you remember that you need to supply some energy so that you can pull the electron out, that energy is called ionization energy, or we say ionization enthalpy. The energy required to remove an outermost electron from, condition is it must be gaseous, it must be neutral and it must be isolated. Gaseous means in gaseous state, neutral means it should not have any charge already, isolated means in a separated state it must be. Yes, it's about ionization enthalpy. Now for example, say you have a gaseous atom. I'll just take it as X. This is a gaseous atom. It is gaseous, neutral, isolated. Now I will remove an electron from this. When I write E minus on the product side, this is reactant side, this is product side. You know how to write the equation. We write reactants on the left hand side, products on the right hand side. When I write reactant on the electrons on the product side, that means the electron has been removed. Clear? Now we are removing one electron from this. So what happens if you remove an electron from gaseous neutral atom? I have told you it was neutral. Now you have removed one electron from it. So how should I write this? I will have to write it as X plus. So it needs some energy, isn't it? That energy is called ionization energy. Energy required to remove an electron from the outermost orbit of gaseous neutral isolated atom is called ionization energy. See, it got ionized now. It was neutral, now it got ionized, it became an ion. Now I have removed one electron, it became positive. What if suppose I remove one more electron and this, see, first I have removed one electron, isn't it? It is called as first ionization energy. What is it called? First ionization energy, removal of one electron from the outermost shell. Now if I take this, again it is in gaseous state. If suppose I remove one more electron, what may happen? I'll remove one more electron from it. What happens? Two positive charges becomes extra now. X plus plus. So than writing this as plus plus, we write X2 plus. Again gaseous state. What is this ionization energy called as? This ionization energy is called as second ionization energy. First ionization energy, second ionization energy. Now let us come to the practical imagination of how actually it may take place. So you have an atom, you have removed one electron, yeah? This was an atom, say outermost orbit, from that you have removed one electron. Whether it is very easy to remove one electron, it's very difficult, but still you have supplied some energy, which energy we call it as ionization energy. You have removed one electron. What happens now? Now nucleus will start pulling the other three electrons closer. These electrons closer. Size goes on decreasing, isn't it? Now cation has smaller size. Now again, if you want to remove the electron, whether it is easy or it is difficult, it's very difficult. Why it is very difficult? Now its size has decreased. Earlier the size was large, but now the size decreases because out of 4 electrons, only 3 electrons are remaining. Nucleus is pulling them closer. Now if you say, I'll supply energy and remove one more electron, you need very high energy. High ionization energy is required. You understand why? Because the nuclear pull on the outermost electron will be very high. Hence, more energy is required to remove the electron. Therefore, high ionization energy is required. So, how do you write? We say that the first ionization energy is less than second ionization energy. That means to remove one electron, you require some good amount of energy, but the second ionization energy will be very high. Otherwise, you can write this way also. Second ionization energy is very high than first ionization energy. Got it? Got the point now? So this is about ionization energy, that is how much energy you need to remove an electron from the outermost orbit. Now let us study the periodic, that is how it varies across the period and down the group. Now I had told you, you understand the concept of atomic size very well now. So now you tell me, across the period and down the group, how ionization energy varies. One more thing I'll tell you, this is for you to remember, that atomic radius is inverse of ionization energy. That means if atomic radius is high, that means ionization energy for it will be less. Clear? So atomic radius high, ionization energy less. Now you see, atomic radius here goes on increasing. So what may happen to ionization energy? If atomic radius increases, then ionization energy decreases here. Why ionization energy decreases? See, here the size is small. So nucleus will be close to the outermost electron. Yes, to the outermost electron, the nucleus is closer. Now if you want to remove one electron, whether it is easy or difficult, nucleus is pulling the electrons towards itself. So it is difficult for it to remove the electron. So you need high ionization energy. Whereas you go down the group, size is increasing. So nucleus is somewhere here and outermost electron is far from the nucleus. Whether it is easy to remove electron or difficult, it's easy to remove electron. Why? You need some less amount of energy to remove the electron because the size is large. So understand, when the atomic size decreases, ionization energy increases. When atomic size increases, ionization energy decreases. Same way, across the period, what happens to ionization energy? Size is decreasing and decreasing. Therefore, ionization energy must be very high because the size is very small. See, nucleus is very close to the outermost shell. So, very high ionization energy is required. So, how do you write it? Across the period, ionization energy increases. Down the group, ionization energy decreases. So, hope you can write the reason for it also. You can, in simpler words, you can write ionization energy decreases because atomic size increases. And you will write the reasons what you have written for atomic size there. Hope it is clear. So this is about ionization enthalpy. Please do remember the trends, and for this you can write the explanation same as that of atomic radii, but you will have to write opposite of it. Hope you are clear with it now. So ionization energy is energy required to remove the electron from outermost orbit.